divided by number of supports, and the same load can be applied in the stead. Now, regarding how the actual scenario will look like, let's just go through some photographs. Over here, in this structure, you can find that on both the side of a staircase, handrail is provided, and again, the handrail is provided across the platform. Here you can see a small platform with a caged ladder. Now, over here, you can see the cage, and in the next picture, it's a platform with excess of ladder without providing a cage. So what's the difference? Why in one picture you can see a cage and in another there is nothing? Well, it varies from height of a ladder. To provide extra safety to a climber, a cage is provided. So when the ladder length is more than 3 meters, generally we go with a cage ladder so that additional protection will be available. While when the platform height is not more than 3 meters, then we can generally go with a normal ladder without having any cage. Now over here you can see a picture of a grating and a checkered plate. Grating is generally supported on a two side. For rest of the two side, it can be freely suspended. Since the main bar will be in only one direction, in that direction only we need a support. While when it comes to checkered plate, we have to provide welding on all four sides of this particular plate. So structural members should be provided in such a way that the all direction the support is provided for this. Now let's talk about piping loads. Piping disciplines generally provides the piping load input for big bore lines. So what is this big bore line? Pipe dia equal and more than 8 inch is considered as big bore lines, while line size below 8 inch is considered as small bore lines. Apart from that, piping provides input for some stress critical lines which are irrespective of the line size. For rest of the small bore pipelines, assumption must be made for the load calculation purpose. As per this document, 1 kN per meter square to 3 kN per meter square operating load must be considered in the design. So for the calculation purpose, 1 kN per meter square load is considered as empty load, while 2 kN per meter square load is considered as a content weight, making 1 plus 2, 3 kN per meter square as a dead load operating condition load. When operating load is available and empty weight is missing in the data, generally 40 to 60% of operating dead load is considered as empty dead load. Test medium shall be specified in the contract document. When such data is not available, water-filled pipe weight is considered for the test load. Hence, for big bore pipeline, concentrated force is applied in analysis software like StatPro in the piping support location, while small bore lines, UDL load is applied for a part where small bore pipelines are laid in the pipe rack. Over here, you can see some photographs. In this particular tier, you can see that a shoe is provided. Shoe is nothing but a supporting arrangement for this particular pipe. So over here, you can see many of the pipes are being supported with this particular shoe on a structural member. Now this is the isometric view of a pipe that generally piping provides for our understanding. You can see at various locations some marking is provided and the spacing will be mentioned. The same pipeline will be running on the plot plan with this L1, L will be specified in that properly executed document. So by reading that, we can understand that what kind of a support will be coming on a structural location. Right now you won't be able to understand, but just let me explain you that this particular diagram shows a anchor support. So in a one particular line, two anchor supports are provided, while rest of the supports are guide. So that way we can understand that what load will be coming and what is their location where we have to apply the load instead can be explained in a detailed isometry that will be provided by the piping discipline to civil and structural discipline. Let's move on to Piperack cable tray loads. Same way in piping load, unless exact information is not available for instru and electrical cable tray loads, following assumption can be made to get the cable tray load. 1 kN per meter square to 2 kN per meter square per level of cable tray are considered for the calculation. Cable trays are available in various widths like 300 mm, 600 mm and 900 mm, where commonly we use 900 mm width cable trays in the plant. Multiplying this width of cable tray and average supporting span, a concentrated load can be achieved, and same will be applied at a cable tray location in a STAAD-Pro. When cables are running horizontally along the length of a pipe rack, supporting beams are generally needed at every 6 meters, and at the turning, support is provided every 3 meters. While cable trays are running vertically along the height, every 3 meters a support is needed. At the end where cable trays are ending, a liable cantilever for cable tray is 1.5 meter. Beyond that, it is not permitted to extend without any intermediate supports. Now let's move on to next load case, which is live load. Before going to that, let me just show you some photographs how the cable trays generally go through. So through column or any tub arrangement, you can see a cantilevers are passed and cable trays are running on top of it. These are the three levels that we are seeing it over here. From the top view, you can see that cables are being laid on such cable trays. So this is the actual site photographs that you can see how the cable trays look like. Now let's talk about the live load case. Live loads are loads produced by the use and occupancy of a building in a structure. These includes the weight of all the movable loads like man movement, tools, miscellaneous equipment and movable partitions. Area specific of maintenance like heat exchanger, tube bundle servicing shall be also designed in this live load case. Generally in stair and exit way, we consider area load of 5 kN per meter square. Same way for operating platform, load 5 kN per meter square is considered in the design. Now when generally in stairs and exit way, we consider area load of 5 kN per meter square. That is little bit more than this, but that's just a round figure that we generally follow. For operating platforms, again we go with a 5 kN per meter square loading. However, in a walkways and access platforms where only occasional man movement will be going to occur, we consider live load as 2.5 kN per meter square, almost half of the operating platform. For maintenance area and storage place where frequent movement of man and trolley movement is expected, live load 6 kN to 12 kN is considered for the design. Concentrated load mentioned in this table is considered for area of 2.5 by 2.5 square feet, considering a maximum movement will be generated on a structural member. So not both the things will be simultaneously applied. You have to select one of them, and based on the requirement, loading will be applied in the STAAD. As per AC 710, a live load for ladder is considered as 1.33 kN for every 3 meter of span.